Hi friends, welcome to follow up. Let's have a look at problem 2834. Find the minimum possible sum of a beautiful array. In this video, we're going to explain a solution based on the use of set data structure. So this problem can be actually regarded as a variant of the classic two-sum problem in leetcode. So here we are given a positive integer n and a target. So an array nums is called beautiful if it meets the following conditions. First, the length equals the given integer m. Second, nums consists of pairwise distinct positive integers. So here we can understand it depends on by looking at the examples and the assumptions that so the nums list should consist of distinct positive integers. So this is the second item. The third item means that there does not exist two distinct indices ij such that they sum to the target. So we want to find the minimum possible sum that a beautiful array could have. So here we have three examples. In the first example, so the output is 4. So the nums can be 1 and 3. So this is the minimum possible. So in example 2, so the thing is 1, 3, 4, right? So if you choose 1, 2, it's not good because 1 plus 2 is 3, right? So we cannot include both 1 and 3 and 2 in the list. So therefore, for this problem, the required or desired list is 1, 3, 4. So in the last example, the target is 1 and n equals 1. So we just choose 1. So here 1 equals the target, but it's not a pair sum, so we can return 1 for this example. So the constraints for the problem are the following. First, n can be as large as 10 to the power 5, and the target is also in between 1 and 10 to the power 5, both set inclusive. So here our strategy will be do the coding or design the solution with the help of the set abstract data type. So actually, if you are interested, you can check out the first example, the first leetcode problem. So that is a two-sum series. So with that said, let's look at the coding. So in the coding, we actually also explain the logic, or we can see the coding itself speaks. So first, we are going to initialize a set. So this set basically is check if we have already have an element. Also, we want to check the third condition here. So this is the one. Another one is a count. So in it, originally, the set contains 0 elements, right? So here, essentially, we are dealing with set because the list consists of distinct positive integers. And the current value, because we want to start from 1, because the positive integers. And next, basically, is a while loop. Well, the count is less than n. So we want to check if we can add the minimum possible integer currently to the set aux, right? So basically, the condition is like if target minus current not in aux. If this condition were true, in other words, target minus current is in the dictionary, then this number plus the current will equal to the target. That's not good, right? So if it's not in the dictionary, so we are going to add this current number into the dictionary, and then the number of elements should be incremented by 1. So no matter this if condition, so we need to increment the current by 1, because the next step we are going to consider include current plus 1 into the set, right? So after we exit this while loop, then the set will contain n elements, right? The sum of this n element will be the sum we want to have. So we are going to return the sum of elements in aux. So here we just do a very verbose coding. So we just return the sum. Actually, you can initialize a result, right? So then each time you have a current added to the dictionary, you just increment the result, and finally you just return the state of the result. But if we write like this format, this is just for the purpose of ease of understanding. So before we make any comments, let's first do a test. So yeah, it passes all the test cases. So essentially, I would say this problem is a variant of the classic two-sum problem. So if you have other variant, you're welcome to comment or come up with other solutions. With that said, that's it. Thank you.